You are required to prepare 5 liters of a solution containing 1.000 times 10 to the minus 3 moles per liter of copper ions. Which of the following procedures would produce an appropriate solution? Well, let's see here. So we have 5 liters. And as far as procedures go, I'm reading dilute to the mark and mix well, dilute to the mark and mix well, dilute to the mark and mix well, volumetric. As far as the actual procedures go, the procedure sounds good. The question is, if I take the grams here, and looks like I have actually 2 sets of possibilities here. That does say choose all that apply. That will give me different moles of copper and different moles of copper sulfate pentahydrate. So what we need is, we need to figure out basically how many grams of each of these, how many moles we need of our copper in each of these. Again, each of these just has 1 copper per formula, so copper metal's just Cu, and this has 1 Cu per copper sulfate pentahydrate. So I guess the approach I'm going to take is I'm going to find out how many moles I need. I know that I have a molarity and I have a volume, so that will allow me to find moles. That's my molarity of copper. I know I have 5 liters. So I need moles of copper from here. Looks like 5 times 1 times 10 to the minus 3rd. Ooh. 5 times 1, exponent 3 minus. 5 times 10 to the minus 3. And I will keep my 3 sig figs and do 5.00. Now what I was saying is that each of these has just 1 copper, so I can put moles of copper sulfate pentahydrate and have it be equal to this number. And the same thing with copper. Since copper is pretty easy, if I knew my molar mass of copper, my periodic table seems to be buried under here somewhere. Is that it? Oh, no, oop, calendar. Well, we will have to look up copper's molar mass. So, not helpful. 63.55. Very helpful. So we'll just put moles of copper. 1 mole. (63.55 grams). 5 exponent 3 minus times 63.55. 0.3177. Well, yeah, there we go. This answer will work. Now let's figure out the molar mass of this big beast and plug it in here as well. And we've got 1 mole of copper, sulfur plus 1 mole of sulfur is 32.07, plus 4 moles of O, which is 64, plus 10 H's at 1.008 each, plus 5 O's. 249.7. And I've got that written down there somewhere. Do the same calculation now again, times 5, x meant 3 minus 1.248. Yes. So these two answers will get us the required solution, the required concentration.